In this video, we will discuss a new way to find the antiderivative or to evaluate some definite integral, a new technique, which is called u-substitution. So let's see a motivating example here. So here we have a function, which is the integral of 2x times root 1 plus x squared dx, right? Now, now, now you can see that this is not one of our elementary functions, right? Not a power function, not none of that, sine, cosine, exponential, right? We don't have a good way to change our function to a sum or difference, a constant multiple of elementary functions. We cannot do that. We cannot split square root, right? So what we can do here is just look at this integral here. The back term is the second factor here. Now you can see that this second factor is a composition of two functions, right? 1 plus x squared is a composition of two functions. The inner function, 1 plus x squared prime is 2x, right? And 2x is actually outside. So this reminds you the chain rule, right? So this is u-substitution is basically the integral version of chain rule. How do we get that, right? So you might wonder whose derivative is outer function. Then you time the derivative inner function. The outer function is square root. Whose derivative is square root by the integration of power function. We know that is 1 plus x squared to the power 1/2 plus 1 then times 1 over 1/2 plus 1, right? Now, if you look at this function, the derivative of this function is the function we have in our integral, right? So this gives you the idea here. So the standard procedure here is we just give a name for the inner function. So let's do a substitution here, right? Let u here equal to 1 plus x squared, which is the inner function, right? Then du is 2x dx, a differential of u for 2x dx. So in this case, we can rewrite our integration 2x square root of 1 plus x squared dx as integration square root 1 plus x squared times 2x dx. Now we substitute this u in our integral. We change it to one of our standard one of our elementary function, right? There should be u here, right? Then this is u to 1/2. We know the integration of power function is u to 1/2 plus 1 over 1/2 plus 1, right? And so this is equal to u to 3 over 2 over plus a constant, 3 over 2 plus a constant. We plug u back in, you get 2 over 3, 1 plus x squared to the power 3 over 2, then plus a constant. So this is the way to evaluate this indefinite integral, right? Which we apply chain rule in a different direction, the backward direction. We get the antiderivative. So the whole method is called, because we always use u as our inner function notation. So this is called u-substitution. So let's try to write down standard statement for the u-substitution, so we can use it whenever we want, right? So this is called the substitution rule, which is also called u-sub, right? And we let u equal to g of x be a differentiable function. We always assume our inner function is differentiable, right? Differentiable function, and we just f here be a continuous function, just to make sure the integral the function is integrable, right? Then integration f of g of x time g prime of x dx, right? You know that's true. Now just do a substitution with u equal to g of x and du equal to g prime of x dx. So this one here can be written as integration f of u du, right? And f should be one of our elementary functions. And then you can apply the rule to get the antiduality of this function, right? So this is called u-substitution. So let's see two more examples. Example one here, we have integration x to 3, 2 plus x to 4 to the power of 5 dx, right? So you can see that this is a very complicated function. It's a product of two factors. And we don't want to change this to a sum or difference of elementary function because that will be very difficult, right? The power 5. Okay, so now you can see that we want to try our method called substitution rule. Why we can do that? Just notice you have a combination of two functions as which is our second factor here, right? And with the inner function to be 2 plus x to the power 4, whose derivative is 4x cubed, but really constant, doesn't matter. So you have x cubed there, that will make sure the method works, right? Let's try to do that. We let u here, u is always an inner function of some combination, right? X2 to 2 plus x to 4. Then du here is 4x cubed dx, right? Now let's try to do the substitution here. So this is equal to integration. Okay, so rearrange the order of the terms first times x cubed dx, because this is productive term, is commutative, so we can do that. So x cubed dx, from this differential here, we know that x cubed dx is 1 over 4 du, right? We want to replace all the term contains x to a term contains u, do a complete substitution, right? Numbers, complete substitution of x by u. Numbers doesn't matter. So this is equal to integration u to 5 times 1 over 4 du. Constant really doesn't matter, so we can bring that out. This is 1 over 4 integration u to 5 du, right? So this is 1 over 4 u to 6 over 6 plus a constant. Final step is always bring the u back in. This is 1 over 24 because 4 times 6 is 24. And 2 plus x to 4 to the power 6 plus a constant. right? This is one method. You can see that through these two examples, u is always an inner function of some compositions, right? Okay, let's see one more example here. B2 integration x over the indefinite integral, right? 1 plus x squared dx. We are looking for the antiderivative of the inner function, right? We do know that integration 1 over 1 plus x squared dx is arc tangent of x plus c. But this is not true here. You cannot apply this formula, and because this one has an actual term which is x, right? You cannot apply our this formula fails, right? Because that's actual x. So this is not one of our standard standard functions, right? So how do we handle this? And but if you look at this denominator here, the denominator derivative is 2x, as we said. If you have a term whose derivative non-constant part exists in the function, you can try to use u-substitution. But let's try that out. So we just let u here is 1 plus x squared. Then du is 2x dx. We don't have 2 in our integral. We change it a little bit. You get x dx is basically 1/2 du, right? So now let's try to do the substitution and figure out this indefinite integral, right? So this is equal to integration 1 over 1 plus x squared. Just try to regroup it and make our substitution easier. So this is integration 1 over u times 1/2 du, right? So this is 1/2 integral 1 over u du, right? And by our, this is in the list of the elementary function. We know how to handle this. So this is 1/2 natural log of u with absolute value plus a constant. So this is 1/2 natural log of, because x squared 1 plus x squared is always positive, we can get rid of absolute value. 1 plus x squared, then plus a constant, right? Because 1 plus x squared is always positive. So the absolute value does nothing, right? Just get rid of that will be good.